All right. Well, welcome everybody to another episode of Crow Canyon's webinar series. These have been incredibly successful. So thank you to everybody who's tuning in today. And thanks as well to Dylan Schwint and Taylor Hasbrook, who have really been the driving force in pulling together the great webinars that we've been having at the Crow Canyon Archaeological Center. I just want to orient you, if this is your first time joining us, as to how to use the Zoom video conferencing webinar service. The first thing to know is that you probably see Grant's head, or maybe my head, hovering somewhere on your screen. You can move that little window around if it's in your way. So move us around, or if you click that little narrow bar there, it'll actually minimize that window. And so if it's obscuring something that Grant's talking about, just go ahead and move it. Throughout today's webinar, I'll be taking questions through the Q&A option at the bottom of your screen. If you hover your mouse over your screen, you'll get a little menu, and you can actually ask a question by clicking Q&A. I'll be watching the questions. If you ask a question that's particularly salient to what Grant's talking about, I might interject and ask that question, but we'll try to get to all the questions by the end. If you're having difficulties with Zoom, you can head over to our live stream on Facebook, and there's a link right there, facebook.com/Crow Canyon Archaeological Center with an AEO, or just go on Facebook and search Crow Canyon, and you'll see the live screen pop up. For all of you joining us on Facebook, I'll also be taking questions in the chat feature on Facebook, so I'll be keeping an eye on that. And then subscribe to us at YouTube, crowcanyon.org/YouTube. This video and all of our past webinars are posted up there with closed captioning. So follow us on YouTube. Just to introduce anybody who's unfamiliar with Crow Canyon, our mission at Crow is to empower present and future generations by making the human past accessible and relevant through archaeological research, experiential education, and American Indian knowledge. And we've been doing that for almost 40 years. We bring participants to Crow Canyon's campus to experience archaeology as citizen scientists, to excavate with us in the field, study artifacts in the lab, and travel with us around the Southwest and around the world, learning about past cultures. COVID-19, this pandemic has really impacted certain parts of our mission, but you're experiencing right now our pivot to doing more distance education and delivering on our mission even remotely, as we all are. So thank you. We've got a couple upcoming webinars. I'm just going to list the next two. Next week, we've got Who Are the Southern Utes? With Edward Birch Box III, our nearest neighbors here in southwestern Colorado. That's next Thursday at 4 Mountain Time. And then the following Thursday, June 4th, we have Sacred Landscape, Sacred People with Jason Nez. So please join us for both of those the next couple of weeks. Finally, I want to introduce our speaker today, Grant Coffey, who is the Research Database Administrator at the Crow Canyon Archaeological Center. Research Database Administrator doesn't cover all of the incredible things that Grant does for Crow Canyon. In addition to managing our 40 years of research and making sure that it's accessible to researchers, to Crow Canyon staff, to descendant communities, Grant also coordinates the data collection for a lot of Crow Canyon's research projects, including our newest data types like drone imagery, 3D models that he'll be talking about today. Grant's been a professional archaeologist since 2001. He got his undergraduate degrees from Fort Lewis College in anthropology and agricultural sciences, and then he has a master's degree from Northern Arizona University in archaeology. Grant has helped lead the Goodman Point Archaeological Project and has been a real contributor to the science and education that we do at Crow Canyon. So without further ado, ado, I want to welcome Grant Coffey, giving a talk on digitizing the past, recent 3D modeling at Crow Canyon. So Grant, I'm going to stop sharing my screen, you share yours, and then take it away. All right, you should be able to share.
Here we go.
Fantastic.
All right. Well, thank you, Kyle. Thank you for that introduction. And also, thank you very much for taking time out of your extremely busy schedule to moderate this webinar. And I'd also like to just echo my thanks to Dylan Schwint and Taylor Hasbrook for doing all of the behind the scenes work to make this happen. Thanks a bunch. Well, thanks everybody for joining me today. This talk is going to be about 3D modeling here at Crow Canyon. And really what I hope to do with this presentation is cover three basic topics. I'd like to talk a little bit about the sites and artifacts that we've modeled and really not get too much into the interpretation of a few of them because they're still ongoing research projects devoted to these sites. But I'd be happy to answer questions that I can. The second thing is I would really like to introduce folks to how we plan to use these at Crow Canyon. Really some of our remote learning and distance learning opportunities that this type of modeling can provide. I hope to cover that as part of this presentation. And third, I would really like to just briefly touch on how the models are created and kind of the technology behind it. So those are the three big things that I would like to do in this presentation. And feel free to ask questions as we go. I'll try to stop periodically so that I can answer any questions that you might have. So probably from the onset, it's probably good to start with some definitions. So what exactly do I mean by modeling? Well, a lot of the models that we're going to see in the following presentation are photogrammetry models. That means they were made using digital photos, and you're essentially creating structure from where digital images were taken and tie points between digital images. You can do this a lot of different ways. These days, there's a lot of drone photography that is used to make aerial composites and digital elevation models. You can also use ground-based photography to create a lot of these models as well. One thing that's really important using this type of technology is to get a lot of overlap in the photos that you take. So just this slide here in the upper right-hand portion of the slide, all of those blue squares are the position of the drone when it took an image below. And since the drones are GPS enabled, and this image over here, this is a DJI Phantom 4 Pro that we use here at Crow Canyon. Since it's GPS enabled, you can know the location of where the drone was when it took a photo. You can also recreate the location of where the image was taken using a software package that I'll talk about here in a minute. It's called Agisoft PhotoScan. We often use other types of data to augment photogrammetry models. One of the major things that we use are total station data or electronic distance meter data and high resolution GPS data, especially when we're talking about sites or landscapes where we're flying drones to create kind of a composite or raster image that covers a large area. Having those kinds of controls is really important. This image down in the bottom right-hand corner is kind of an example of that. Hopefully you can see there's some numbers and these line drawings on top of this aerial composite. And really what that is it's a AutoCAD map created by Neil Morris that's superimposed over a really high resolution aerial image. So a lot of the value in this type of work comes from layering and putting different layers together to try to create the most accurate model that we can of sites and contexts. So what are some potential uses for these models? Left-hand side, you can see 4 things that I've outlined. And of course, there's a lot of commonality between these topics, and they are intertwined to some degree. But research, if you have a really highly accurate and precise model, a researcher could come in to say this structure that's identified here, and you could look at the size of the stone in the masonry. You could look at the distance between architectural features. You could do volumetric calculations of how much stone is used, how much mortar might be used in some of these structures. Just to give folks kind of an idea of what this particular image is, it's an excavated kiva at the Haney East Great House that's part of our current ongoing field project, the Northern Chaco Outliers Project, and it's also part of the Lakeview community that we'll talk a little bit more about in just a minute. It's important to note, I'm going to show a lot of photos like this. Crow Canyon didn't actually excavate this kiva. This was already excavated by the time Crow Canyon came to do the field work out there. So just to give you a little bit of background on this particular structure. Education, obviously today's world, there's a lot of distance learning and remote access interest, especially in the digital world. So you can imagine building curriculum about how many trees or timbers you might actually need to roof this particular structure. How much labor would it take to collect all this stone and shape it and put it in the building where it goes? A lot of different topics that you could address with education, that you're actually using a quantifiable model to ask the questions, and then you can share that at a distance and use it really in a lot of different ways. Outreach, kind of along those same lines, there's a lot of Native communities and other interested folks who really are interested in the sites that we're looking at and what we're finding. And so creating these really accurate models provides us one way to share the results of our projects to people who may not be able to travel to the Cortez area or to the Mesa Verde region for whatever reason. So really providing outreach to Native communities and other interested parties is another real benefit of creating these models. Finally, preservation. One treatment oftentimes for excavated structures is to backfill them, to preserve different architectural elements and try to keep the standing masonry that's still there intact. And by backfill, what I mean is you come in and you put a lot of sediment and fill in here to stabilize the structure itself. We haven't done that with this particular structure yet, but we've done it with a lot of the archaeological structures and contexts that we've excavated, just about all of them in the past. And so once you backfill it or fill it full of sediment, you really need an accurate record of where everything is so that you can preserve what was exposed, and future researchers and interested parties can come back to that model and use that since it's all buried. So just to kind of provide a context, I guess, how long have we been modeling stuff at Crow Canyon? Well, going back to the very beginning of Crow Canyon, we've been modeling. We've got replica structures like the Pueblo Learning Center. Up on the hill here behind the building I'm in, we have the basket maker Learning Center just up the hill here behind us. So we have replica of entire structures. We've got vessels. This is a vessel, we affectionately call it the Logo Bowl. It's a replica of an actual bowl that was found at San Canyon Pueblo during the excavations there, which was a really early excavation project for Crow Canyon. Paul Ermaggiati, who is really skilled in a lot of things, but he's also an educator here at Crow Canyon, produced this replica vessel that we still have in our lobby over here in the Gates building. And it's really the template for the logo that you see that Crow Canyon has. So it's really a fantastic vessel that Paul did. And all of this is really just to say that modeling in some way, shape, or form has always been a part of the Crow Canyon experience, trying to replicate, trying to model sites, features, context, artifacts, and that's something that's ongoing today. One of the earliest projects that we had that actually uses digital photos and other kind of vector data that is essentially X, Y, and Z coordinate points to reconstruct archaeological context. Down in the right-hand corner of this slide, you can see this gentleman is Jim Homeland, who owned Western Mapping Company. And this is a laser scanner, or kind of a ground-based LiDAR instrument that he went around and actually scanned this entire excavation unit. This is a 2 meter by 2 meter excavation unit that we dug into Kiva 107 at Goodman Point, Pueblo. So the way this works is it shoots out a laser and it measures the distance from when it actually hits something till it comes back to the instrument. And so what you get is this point cloud of this vector three-dimensional data, all of these little tiny pieces of data that essentially look like a cloud around the interior. And it's a really precise way of mapping archaeological features and contexts. Once that is done, once you've gone around with your scanner, your laser scanner, and gotten every face or every portion of the excavation that you want to map, you go around and you take digital photos. And you can overlap those digital photos much like you can in the photogrammetry software to create a texture or a really highly accurate mesh to put over the point cloud to make it really realistic and highly accurate. So this particular video is basically the results of this project where we scanned structure 107. Just to orient folks, this is a pilaster on the interior. And by pilaster, what I mean is a masonry column that sits on a bench surface. And there's actually 6 of these in this structure. And there would have been timber spanning the pilasters to support the roof. We'll see more about that in just a second. This is the bench face, which is a masonry circular wall that encloses the structure. This big slab here, this is actually a deflector slab. It's between a vent tunnel, this structure here, and the hearth, which would be right back here. So it's intended to divert air around the structure, which would be coming in a ventilation system here on the south end. So hopefully from this video, you can get an idea of the value of really pairing this highly accurate scanning technology with, really precise digital photos. You get a feel for what the interior of the excavation looks like. You can also use this for some interpretive results. For instance, in this is a burned stratum of fill in here that included some burned roofing timbers, some really large pinyon and juniper, mainly juniper timbers that were used to roof the structure. At the time it was decommissioned, part of the roof at least was burned, and it preserved those rings. And in the individual specimens, it preserved the tree rings. And one of the specimens we got out of this structure dated to 1265, AD 1265, and that's a cutting date. So we know this particular structure was built and occupied probably in the last 15 years before regional migration from the Mesa Verde region, which is really, really an interesting thing. So in terms of curriculum, you can imagine providing videos and things like this to a lot of different groups, everyone from middle school up, and maybe elementary school too, that can take a rendering like this and really get a better feel for how these things were put together and use that information to really assess them in a more quantitative and systematic way, and really learn a lot about how folks lived in the past up here. So this particular video, you can see this is one of those pilasters, one of those cubes that's resting on the bench here. Basically a column of masonry that would have supported the trees going from one to the other, or the logs that would have actually roofed the structure. This is the hearth here, where they would have had fires, would have provided heat and light to the structure on the interior, and all of this would have been basically below ground. This is the vent shaft that goes vertically down and then connects horizontally to the vent tunnel, that opening that we saw down there. So even though this was one of our earliest attempts at creating, three-dimensional content from photos and other vector data, it's really pretty interesting and compelling in a lot of ways that still photos really aren't. Any questions? I'm covering a lot. Kyle, is there anything in particular? that folks are interested in?
We've got two questions. One's from me and one's from Dwight. I'll ask Dwight's first. Dwight asked just how big were those kivas, just to give people a sense who maybe aren't familiar with them.
Yeah, they vary, but I'd say on average it's about 3.5 meters across. So pretty large kivas, up to 4 meters across. Some of them are even larger. When you get into the Chaco era up here in the Mesa Verde region from about AD 1075 to around AD 1140, there are some really large kivas that are a little bit bigger than that standard domestic one I just showed you, that look to be extra domestic. And then, of course, there's these things we call great kivas that go all the way back to Basket Maker 3 times, that are 10 meters or more in diameter, really large structures. But those look to be communal in nature, not necessarily associated with individual households.
Great. Thanks, Grant.
Okay. Well, moving forward in time, up to 2016, this is the East Great House at the Haney site. And over here on the right-hand side, you see kind of a plan map of the Haney site. So looking straight down on it, this is the East Great House that I've talked about just a few minutes ago. And this is a model of the East Great House that was made from photogrammetry, basically taking a lot of different photos and stitching them together using Agisoft photoscan software. Susan Ryan got a grant from History Colorado and the State Historic Fund to fund all this work. And what happened was we ended up contracting with Paleo West. This is Ben Hammer, who was a mapping and photogrammetry specialist with Paleo West. And they did all of the actual photo capture and model creation. This is a still. We'll look at kind of an interactive model of the East Great House here in just a minute. It's probably important for me to define what I mean by great house. Great houses up here really part of the Chaco phenomenon and generally date from about AD 1075 to around 1140. Some of them persist longer, but often they're multi-story. They've got above ground kivas that are blocked in with masonry. It's really interesting at the Haney site to have two great houses so close together. Oftentimes they're separated by kilometers, and they're thought to represent, the building activity of a single community. So one thing that's really interesting at the Haney site is how close the great houses are. And there are in fact two other great houses nearby that collectively we refer to as the Lakeview group, that are all within about 800 meters of each other. And that's a really rare thing up here in the Mesa Verde region. So that's a little background, hopefully, on the site. I should mention that currently our field crew, Kellum Throgmorton and Steve Copeland and Tim Wilcox, they're actively out working in the Lakeview community. And they're finding out new and interesting things every day. So some of the images that I'm showing you are a little bit dated, but that they'll have a lot more to say in upcoming publications and presentations about the Lakeview community, I'm sure. So this is an image of Ben Hammer, and what he's holding is a big telescoping rod that you can fit the camera on top of. It actually snaps in. And on top of the camera is a GPS device. It's a really small GPS device that actually geotags every image that Ben is collecting. And one thing that you can't see from this image is there's actually a remote shutter, a little button that you push to take an image every time you want to take a photograph, digital image. And the reason he's doing this with the long pole is he's getting a lot of oblique shots of the East Great House at the Haney site so that he can tie all of the other imagery that he's taken together to create a model. You could do this with a drone, but really the ground-based photos often work better for creating three-dimensional models using the photogrammetry software. So it's really, there's a lot of different techniques that you can use to capture the image that you need to create the model. This has also been down here, and you can see he's really squatted down. He's trying to get images of every part of the structure, and he's trying to collect images that overlap by at least about 50 or 60%. So 50 or 60% of one image is the same as the next image, and so forth, because that overlapping, like we talked about, is really important for model creation and creating the tie points to create digital models, 3D models. So just kind of an overview of the work that we did, and I assisted Ben a little bit, but really it was his work. This is the camera. I used a Nikon D7200. It had a 10 millimeter focal length, so between the lens and the actual center point in the camera that collects the image. Took just shy of 3,000 photos, so a lot of photos, a lot of digital storage was involved in creating the model. Ground resolution of about 1 millimeter when the model was finally created. That's not the individual photos, but that's the model itself, the actual skin of the model. And just shy of about 500,000 tie points. And what those tie points are, it's recognizing key points in digital photos, and it's looking for how many times those key points, these pixels in adjacent photos, show up in other photos. So if you have the same key point, the same pixel in 2 photos or more, it creates these tie points that between the focal length, the focal length of the camera, the tie points, the angle of where the camera was when it took the image, it creates all of these. It's kind of like LiDAR. It's a point cloud of data, a 3-dimensional point cloud that you can then use to create meshes and actually texture with photographs, like we saw in the Kiva 107 example just a minute ago. This is Haney West, the other great house there. This one has been almost completely removed by mechanical excavation. Not completely, they're finding more all the time, but this is what was standing when we did the work in 2016. And this image over here actually shows where the camera was each time an image was taken. So the software in tandem with stitching everything together, before it actually does all that, it figures out where the cameras are in relationship to these tie points that are in the model, and that are subsequently used to create a dense point cloud and then a mesh, which is just like a skin to the model. So you can see there was a lot of photographs taken, 887, really good ground resolution and a lot of tie points. Not as much as the Haney East Great House, but still a lot of photos and really good resolution. I'm going to go back just one. I forgot to mention this figure here, and this is the Haney East Great House. If you can see these halos of red dots, those are where the camera was when Ben was actually using the painter's pole, that telescoping rod, to take images. So it's really, really interesting, not only to see the model itself, but how the capture takes place to create a model like this. So in tandem with the ground-based kind of detailed modeling that we did of Haney East Great House and Haney West Great House, we also did some drone mapping out there. This bottom right-hand image is actually a still shot from a video that was taken. You can actually see the drone props right in here. Took some aerial video of the site just for, preservation's sake and to get a good feel for what the site looks like from the air. This image up here is a representation of the aerial photographs, all stitched together to create what we call an ortho mosaic. So just basically a mosaic of all the different images stitched together to create this rendering. These blue dots are where the drone was every time it took an image that was used to create this. So you can see it's really systematic in what we might call a transect pattern. Back and forth, back and forth. Ben used a software package called Drone Deploy to program the drone to fly at a certain height with a certain amount of image overlap, and it really automates the flight of the drone. And what you get is a really systematic pattern that gets you great coverage over bigger areas. This is an infrared image. We also flew infrared camera over the Haney site. The green areas are areas where the vegetation is growing a little bit better, and the red areas are hotter areas where vegetation is not growing so well. Now, one thing that we use the infrared imagery for is trying to detect really subtle landscape features. Sometimes linear features like ancient roads or trails will show up in infrared imagery. Infrared, a lot of folks are probably familiar with it. It's a part of the electromagnetic spectrum. It's just beyond or outside of our visible spectrum. So things like heat, that's how we detect it. A lot of disturbance out at the Haney site. So the infrared, we have yet to really identify anything substantive from that, but it's really good to have it as part of the record, and you never know until you look, I guess. And then this is the image, same kind of mosaic. It's got our line drawing of the site map on top of the Haney East Great House. This is one of our primary datums over here on the East Great House. So just briefly, the results of all this work, we created the models that we'll look at more in just a second. This is an image here. This is another great house that's part of the Lakeview community, a site called the Wallace site. And in the distance here, this is the Haney East three-dimensional model that we looked at just a second ago. And this is the Haney West great house model. One advantage of doing all of this type of work is that you can actually create a three-dimensional landscape that has all of the features on it. You can program virtual tours and really get a better sense for where things are located on the landscape in respect to each other. So just really briefly here, I'm going to stop and go to a site called Sketchfab. This is a website, and basically it's a clearinghouse for three-dimensional models. And what we're looking at right now is the three-dimensional model of the Haney East Great House. We've uploaded a lot of our models to Sketchfab. If you go to sketchfab.com/Crow Canyon, you can see some of the models that we've uploaded. This particular model of the Haney East Great House and the West Great House, these are up there, but they're restricted right now because we're trying to figure out precisely what kind of curriculum we want to develop for these. And it is ongoing project where there's a lot of things changing back and forth. So we really just want to think this through and see how we want to portray this to the public. But if you see these numbers here, these are little annotations that you can add to the model to explain what you're looking at. You can add a lot of these. You can add additional content like links to videos and other content that you may not be able to fit onto this particular model. But you can imagine where, in terms of curriculum or in terms of research, you could use models like this to really enhance kind of the user experience. It really gives you kind of a better feel for what the site looks like than maybe a line drawing or a plan map, or even a still photograph, because you can navigate around and look at different structures from different angles and so forth. One really nice thing about Sketchfab is you can also have the capability to view in VR, virtual reality. So if you had a Google Cardboard or maybe some of the higher end Oculus virtual reality viewers, you could open up one of these models and actually take a virtual tour through the site. And again, you can imagine where that would be valuable in terms of research collaboration or education curriculum, either one. And just to let folks who may not be able to visit the site actually get a feel for what it looks like. So that's kind of the modeling work that we did at Haney so far. We're still doing a lot more modeling at the site, and we'll continue to going on into the future. So moving up to 2017, this is a pit structure called the Ridgeline pit structure, which is over just to the west of us here at Crow Canyon. And this particular structure is actually also shown on this map here. So what we're looking at is basically the eastern half of an excavated pit structure, and that's what's being portrayed over here. This particular structure dates to the Basket Maker 3 time period, so somewhere from about AD 500 up to about AD 750-ish. We're still waiting on some tree ring dates to nail down more precisely when the structure was built. And Shauna Dietrichs, who was the project director, is just getting ready to finalize the report for the Basket Makers Communities project. So she'll have a lot more to say about the interpretation of the structure and, its importance than I will today. But this is a drone photo of one of the upper surfaces. And these two are just still shots of the model that we'll look at here in just a minute. So before we start spinning the model, just a few folks who are critical in getting this site on our radar and actually part of our excavation program. This is Jane Dillard, who owned the property, and she's been a Crow Canyon supporter for many, many years. Among other things, she helped in the lab for I don't know how many years, but a lot of years. And she's just a really great friend and supporter of Crow Canyon. So we were really privileged to be out there doing any excavation at all, and that was thanks to Jane. Steve Copeland, he supervised a lot of the work out at the Ridgeline pit structure. He's been here at Crow Canyon going on 15 years, so he is one of our key field personnel. And this is Shauna Dietrichs, who was actually the project director for the Basket Maker Communities project. Before I start spinning the model, just to give folks an idea, just like on the drone footage, all of these blue squares are the location of an image in relationship to the model. And that's figured out by stitching them all together, looking for these key points in individual photos, doing something they call a sift, looking across them, and then finding these tie points that relate one photo to the next, kind of like stereo vision, only it's looking at all the photos to create this three-dimensional point cloud that then becomes a mesh that then becomes textured with the actual photographs themselves. So this is just an animation of the structure here. This is what we would call the antechamber, or small room to the south. This is a main chamber, a bigger chamber, usually just to the north. One thing to note, this is down on the lowest surface, what they call surface 3. And you can see the bench face. There are a lot of upright sandstone slabs. A lot of these, almost all of them probably, were plastered over during the final use of the structure, but it gives you a pretty good idea of the construction of this bench area here. And one thing that you might be able to see, there's a lot of little depressions in the bench that goes around the circumference of the main chamber and around the antechamber too. And those would have seated posts. Those are little post holes that would have supported the roof of the structure. One thing that hopefully you can see in here is all of this black fill. That's burned roofing debris. That's burned roofing timbers, closing material, and other things that we did get a lot of tree ring dating specimens anyway. We haven't gotten the dates back yet, but we did get a lot of specimens out of that fill that hopefully will help us nail down the construction maybe to the year. We'll have to see. Here's the hearth here. So this would have been the fire pit for the structure. Just coming around on this side over here, there's what we call a wing wall. And this is a big sandstone slab that's set in the floor. And this is a post hole. This would have been kind of the southeast primary post hole for the main chamber in here. And this is actually a little wall that was built to segment the space inside the main chamber of the pit house. So just moving forward, one thing that's important about the Ridgeline pit structure is it's really big. It's what we call an oversized one. It's at least a few meters longer and larger than your average domestic pit house that you find up here during the Basket Maker 3 period. It's just shy of about 11 meters long. This is a reconstruction that Joyce Kramer, actually a former employee here at Crow Canyon, put together. So just to orient folks, like this would be the antechamber that I'm talking about, this smaller space down in here. This would be the main chamber, this section back in here. You can see the wing wall that's in this reconstruction coming right through here, incorporating a post, really a similar design. Hearth in the middle. And then you have all this covering material and maybe access through the roof. Other folks, different structures may put the access kind of ground level coming through here. But hopefully that gives you an idea of how, for planning for curriculum or trying to just explain this to the public, it's really nice to pair these three-dimensional models of archaeological sites and contexts with kind of replica or models of what we think they look like to give people a better understanding of what we're finding. Just really briefly, I don't want to talk about this one a whole lot, but this one is a model of the same structure, but you can put on contour lines. The blue area here is all a section of the floor that's within 2 centimeters of the same elevation. So hopefully in the future, folks, researchers and school-age children, whoever would like to use the model, can come back to this and hopefully ask and answer questions that we may not have even thought of while we were excavating or recording the structure. From my perspective, say if I forgot to record the exact width and depth of a post hole over here on the bench, you can actually use the three-dimensional model to come back and fill in the data that you may have missed in the field. Any questions, Kyle?
We've got a few, but I think I'll hold them to the end.
Okay, sounds great. Sounds great. Thank you. Moving right along, this is a site called the Cross Canyon Stone Circle. A really important, really large site that's located to the north and west of campus here. This lady, Virginia Wolf, has done a lot of work, probably undoubtedly the most academic work at the site. She was really critical in recording it originally and has spent more time really on the ground out there than any other scholar that I know of. This is Mark Varian, who's the executive vice president here at the Research Institute, and all of the images that you see were collected during a visit with Virginia and Mark. One thing that's really interesting and important about this site is that if you stand in the circle at the winter solstice, the sun rises right along the highest peak of Sleeping Ute Mountain, which is in the distance, and really you can just see the peak of it. So one idea for this structure is that it's a solstice marker, at least in part. It's really an interesting site. There's rock art panels in different parts of the site that really appear to date maybe to the early Basket Maker 3 period of time. There's not a whole lot of artifacts on the surface, a few plain grayware sherds, a few flakes, but we have yet to get really good dating information on this. Scott Ortman with the University of Colorado took a field school out there, and they did some OSL dating, actually optically stimulated luminescent dating. I think I got that right, where you actually lift up the rocks and you analyze the sediment underneath the rocks to see the last time that sun shone on it. So Scott's done a lot of work. The results of that work are still kind of being debated, and I think Scott is currently working on that. But the bottom line is, at this point, we really don't have a super firm date for the stone circle. About 47 images were used to model this, and if I had to do it over again, I would take a lot more photos using the drone of this particular site just to get a better resolution on the ground. But even with 47 images that were used to create the model, you get pretty good resolution at the level, I put down photo targets, and you can check your accuracy with these models to see how far off you are in terms of distance from one point to another, because your scale bars that were placed on the ground were a certain distance apart, and you can compare that to what it is in the model. So you have a way of actually quantifying your error. And on this one, it was a couple centimeters of error over the entire structure. So it's really still a pretty good model, even with not that many photos. 35 meters across, really large, a lot of stone. And then portions of the circle are actually native sandstone that weren't moved. It's just a natural outcrop of stone that makes up part of the circle, but a really interesting site. So one thing that we can do with 3D models and photogrammetry is try to estimate the volume of different parts of sites. So on this one, what I did is took the aerial model that was created from the drone aerial imagery, and I just clipped out everything except the part that I thought might be remnants of the wall. And then I closed the holes underneath just to close the mesh so that you can create volumetric estimates of how much stone may have actually been inside the wall at one point. Again, it would be nice to go back and take more photos to make this better resolution. Another way to do it is to just use ground-based photography to collect the digital images from the ground. And that's what this smaller model is. It's a section of about, just under 3 meters wide this direction. So this is a image of this particular section of the wall. And what we did is we just picked a representative section, did the same thing that this does, basically took a lot of photos, stitched together a model, but it's a lot more precise. And then we close the holes underneath to come up with volumetric calculations of how much stone may have been involved. It's about 114 meters long around the circle. And it turns out, at least in this section that we modeled, there's just under a cubic meter of stone in this section. Actually, that's what we found from this modeling is that there's about a cubic meter of stone in every meter of wall length. So around about 110 cubic meters of stone was used to construct this. And from that, you can get labor estimates and other important anthropological data that's quantitative and replicable. Other people can take your same photos and check that. This is a site called the Solstice Boulder Site. Really another interesting one, not too far from the Cross Canyon Dance Circle or Stone Circle. There's a little low row of rubble around here, and then there's big boulders. On at least one of the boulders, there's this rock art. And if you can see, hopefully they're kind of triangular figures, broad-shouldered, narrow-waisted. They really look like San Juan anthropomorphic figures or rock art that up here would have been made from about 1000 BC to around AD 500. So at least part of the site and dates way back in time to some of the first agriculturalists in this part of the world. An interesting thing about this site, I don't know if you can just see it under there. There's a gap underneath this boulder. This boulder kind of spans these two boulders. And if you're standing here looking through here, it also frames the highest peak in Sleeping Ute Mountain. At a time, well, it frames it all the time, but during the winter solstice, the sun rises right along the highest peak of Sleeping Ute Mountain. When viewed, if you're standing in here looking underneath that rock on the top. So potentially another winter solstice marker that really has some time depth based on the rock art that's present. So this one, 92 drone-based photos. You can see I collected a bunch that were looking straight down, and then I took another halo of photos kind of oblique to try to capture the variability in the vertical topography of the boulders themselves. I also collected quite a bit of ground-based photography. All of that has not been completely integrated into the model at this point. You can imagine the computing power that's involved in creating some of this stuff. It takes a lot of CPU power. It takes a lot of memory. And so you have to be pretty judicious about how many photos you include, and you have to really think hard about return on processing time, especially depending on your computer system. So moving forward, this is the Carvel or Crosspatch site. This is a plan view map of the Carvel or Crosspatch site, and it's owned currently by Gary Weinmeister, who's a Crow Canyon supporter. He volunteers in the lab. Really a great friend to Crow Canyon, and he allowed us to go out and do a lot of the work that we use to map the site. This is a drone image of portion of the Carvel or Crosspatch site. The flight was actually done by Doug Gann from Archaeology Southwest, and then I did all of the computer processing to create the ortho photos and the digital elevation models. So it was really a collaborative effort. Just briefly about this site, all of the red circles that you see are excavated kivas or pit structures. Prior to the time that Gary purchased the land, there was a lot of mechanical excavation at the site. So like the Haney site, there's been a lot of disturbance there that we were able to document using the aerial photos and another method I'll talk about in just a minute. The blue circles are inferred kivas or pit structures, and all of these are room blocks. Really an interesting site for a lot of different reasons, but particularly in the southern part, there's a strong Pueblo 1 component, which dates to the 800s. In the northern part, there appears to be more of an occupation in the 900s and into the early 1000s, and even a really large structure here that potentially could be a proto-great house or the remnants of a very early great house. But we don't know that for sure at this particular time. So just looking at the digital elevation model down here in the bottom, all of these dark circles are depressions that you can see. This image up here is kind of wild, but basically what I did was I took the extent of the pit structures and just draped them on top of the digital elevation model. So the red polygons are actually excavated kivas, and the blue sections look to be the remnants of room blocks. All of the white dots that you see, those were GPS points taken with my phone using an app called Avenza. And what it allows you to do is use your phone GPS to record your position, and then you can drop pins on a georeferenced PDF, for example. So you can actually use your phone as a GPS, and you can add notes and things to it. It's not the highest resolution, but it's usually close enough to at least take notes about particular structures or to take photographs and actually tie them into your 3D model or your rendering of the map. Moving on to the Jensen site, this is a really important site that Deb and Robert Jensen allowed us to do some work on. This gray area here is the remnants of a great house that's kind of in the middle of the site, another one of those Chaka era great houses, it looks like. These white outlines are room blocks, at least as we have them defined. And then these thicker white lines, those are pit structure or kiva depressions, as we have them outlined, and these are middens. So really, a lot of folks living right around the great house at the Jensen site, and really it looks to date to the late 1000s to early AD 1100s is what most of the pottery that we looked at dates to. So in this particular one, instead of using the Avenza app, we used our total station or electronic distance meter, set it up on datums, took shots, all of these little white dots that you'll see. Those were total station shots that we took. And we also flew the drone to create orthomosaic and digital elevation models. Again, at the Jensen site, there was mechanical excavation. Down in this figure here, you might be able to see there's a depressed area that also corresponds to this area here outlined in black in the digital elevation model. And that's mechanical excavation through portions of the great house. So one thing that modeling like this can do is help you actually quantify the amount of disturbance that may have taken place from previous excavations prior to the time that Deb and Robert owned the property. Another thing it can do is allow you to estimate pretty precisely how tall structures are and how much volume they have. Just like with the cross canyon circle, you can calculate the volume of how much rubble and stone is still in the remaining portion of the great house. You can also take your total station shots, which are the red dots here. All of the red dots were taken with the total station. You can take those elevations and go up and actually measure how high existing rubble and things are at the site. So in this particular one, it ended up being a little over 2 meters, I think 2.4 meters. So really substantial masonry still intact at the site. Just really briefly, University of North Texas did some drone work out here in 2018, and it was part of a National Science Foundation grant that Lisa Nagaoka and Wolverton got to come out and actually look, Steve Wolverton, to come out and actually look at the conditions under which maize agriculture can absolutely fail. And as a part of this, they flew over sites that we were excavating that were part of the Basket Maker Communities project. This is another Basket Maker era pit house here. You can see the main chamber and the antechamber. And they also flew over our Pueblo farming project gardens. This is Paul Ermigiati, who, when he's not making pops, records all of the corn that we grow here on campus that's part of the Pueblo farming project. And just really briefly, it's an incredible project, and there's a great webinar that Mark Varian and Paul Ermigiati did available on the Crow Canyon website that really outlines and discusses the Pueblo farming project. But essentially, we've been growing traditional Hopi varieties of corn here on plots and fields on campus. And every week we go out and we record the height and the growth development of the corn. And then we, of course, record how much yield comes from those particular plots. And the goal is to see how traditional varieties of maize perform in the Mesa Verde region that are grown using traditional methods. And that's just a really brief overview of the project. And this link here actually will take you to an ebook that covers the Pueblo Farming Project, pfp.crowcanyon.org. And I would encourage you all to go visit that. It's got some great content about the project. Just briefly, this is what we call the check dam garden. And this garden here is the same as this garden on the image above. So on this image, it's pretty much going straight north. This line here is going straight north-south. And so this image down here is looking a little bit oblique to the southeast. So the image was basically taken kind of looking this direction if you were in a drone looking right through here. And one thing that shows up from the modeling and the drone work, and this is an infrared image superimposed, the green and red one. It's an infrared image superimposed on an aerial image. But from the infrared, what you can see is the areas with better vegetative growth are green, and the drier and hotter areas show up as red. So in the check dam garden here and here, you can see it's situated in an area where there's a lot more vegetative growth. And you can see it on the aerial imagery as well. And that's really been one of our best performing gardens that's been part of the Pueblo Farming Project. So it's just another line of data for looking at maize productivity in this area and using three-dimensional models, not just to recreate context or artifacts, but it's actually as a research tool to try to quantify how much vegetation grows around a particular field and how much the yields from that particular field can be in terms of the maize that you get off of it. You can see this one's red. That one is one of our driest and traditionally one of our most poorly performing fields out there. So really an interesting study that got some really great data. Looking at vessels, we started modeling vessels using photogrammetry here at Crow Canyon. Been doing it for a number of years now. This is a vessel that we found during the Basket Maker Communities project that we'll talk more about in just a minute. This is part of what we call a stirrup mug. It's actually two small mugs, kind of look like a coffee cup, joined by two handles. So there would be just a mirror image of this portion of the vessel over here, and it would be connected by two handles. I include this slide just to show all of these are illustrations by a former intern, Sarah Hibben. And she was really a gifted artist, really put a lot of time into these reconstructions. And hopefully what you can gather from this is that even though these models can be really accurate, they can be very precise in terms of their dimensions. There's certain things that just an artistic person who looks at it and is able to recreate the design elements, it adds a depth to it that even some of the 3D models can escape you if you don't have that keen eye for what you're looking for and being able to represent that to other folks. So I think there'll always be a place in archaeology for really good illustrators who not only can replicate how vessels look, but can also bring a lot to the table in terms of interpretation. Really briefly, this is the Badger House jar that we were just looking at. It's actually looks to be an effigy vessel, Minkus black on white, so probably made in the late 1000s, maybe early 1100s at this particular site. Took halos of photos. These are all photos that were taken and used to recreate the model down here. And the way we did that, it's really difficult to see in this image, I'll grant you, but there's a lazy Susan or a rotating table underneath a black velvet base underneath there. And so what we did is made the camera stationary and then rotate the lazy Susan or the table underneath it systematically to get overlapping photos from different angles. And that's essentially how that model was created. We're still fine-tuning our procedure for sure. Just another example of a vessel. This is a bifurcated basket applique or effigy that was found out at the Carvel or Crosspatch site that Gary Weinmeister was generous enough to share with us. These are really interesting artifacts. They appear to date mainly to the 1000s, but they may even have roots back to Basket Maker 3. There's been some that have been found in Pueblo Bonito and Chaco Canyon. There's been more that have been found at later sites in northeastern Arizona. A lot of different ideas about what they are, but they do seem, particularly in this period of time, which would probably be the very late 900s or 1000s, during this period of time, they're probably tied into the Chaco system, and they're probably representative of a certain idea. People have thought that they represent essentially fertility and abundance of maize harvest. Other people have suggested that they may correlate with especially women's societies, which is really interesting in the framework of Chaco. But anyway, a really interesting artifact that we were able to model in 3D and preserve it in that way. Following up to San Canyon Pueblo, we partnered with Routescene, which is a UAV hardware and software manufacturer out of the United Kingdom, to fly a drone over San Canyon Pueblo, which was a really important site that Crow Canyon excavated and did work at from about 1983 to 1992. There's around about 90 kivas. There's probably 420 rooms-ish. So really a big settlement that dates to the later half of the 1200s, basically from about 1240 up to around 1280. Canyon of the Ancients, they're the agency that manages it. We partnered with them as well, and Caddis Aerial actually flew the drone to collect the imagery. And what we're looking at here is the result of a LiDAR flight. So not quite the same as photogrammetry. It's more akin to the Structure 107 scan that we did, where you're actually flying a drone, it's shooting a laser, and it's measuring it back to create a surface. And this image down here, hopefully you can see, shows all of the trees that are on top of San Canyon Pueblo. And this image here and this image here are from roughly the same perspective. So the architecture would wrap around like this, just like it does here. But it's got a lot of vegetative cover on it. And so what Routescene did was they flew the drone, collected the LiDAR, and then they stripped the trees off the top of it to create this bare earth model over here. And what you see in terms of the white lines on top of the model, that's a line drawing that Crow Canyon made based on the work that we did there in the 80s and early 90s, a simplified version of it. It's really interesting. You can see all this row of kivas, which would result in kind of depressions from the surface, circular depressions. It matches up really well with what is shown on the bare earth LiDAR model. This is a D-shaped structure here. You can see that the kivas on the interior really match up well. By D, I just mean it would look kind of like a D if you were looking straight down on it with two central kivas. Really an amazing project and an amazing result that I think we'll be able to use for a lot of different purposes, education and research, both. These are just some of the models that we've used. This is a model of Crow Canyon campus that was produced from the UNT drone flights that were done. This is another one of the bifurcated basket effigies that Gary Weinmeister shared with us. This is another pit house that was part of the Basket Makers Communities project called Mueller Pit House. So we've got a lot of other models. Basically, kind of getting close to closing here. The goal of all this is to create really some models that have depth in terms of what's being represented, what's being shown, create highly accurate and precise renderings that look at different things. And you really want to stitch all of those things together to get a more complete look at archaeological sites and contexts. And I think 3D modeling, photogrammetry, LiDAR, and other techniques really provide a means of doing that is really important in archaeology, especially in today's archaeology. So looking forward, we hope to use really standardized techniques to collect the imagery that we need to produce the 3D models, try to make efficient use of it as much as we can, given our computer capacity at present, and we're working on getting more. And really just help relay what we're finding in this marvelous part of the world, the different landscapes and the different archaeological sites. Relay that to interested members of the public and school-age children and descendant groups. And I think it's a really effective way to do that, and we're gearing up to do more and more of it. So thanks a bunch. I appreciate you all joining me today.
That was really, really great, Grant. Thank you so much for sharing all of that. I just love seeing it all put together. We've got a lot of great questions, and many of them are technical. Others are interested in other elements. But I want to start with a general one from Katie. And you just touched on this. She was asking, is Crow Canyon planning on using these data sets for additional outreach and education? And what are the opportunities for volunteers, interns, or students to learn how to use these technologies at Crow Canyon?
That's a really good question. Kind of the short answer is, we've tried to involve college field students in the past who have been part of our program in terms of data collection and even processing. So we're trying to branch out. As you can imagine, aspects of it, especially the processing, are kind of a bottleneck in terms of how many people can be involved. But the data capture and really most of the other process is pretty open to involvement with other folks. I would say that we really hope to branch out more in terms of, we looked at the Sketchfab site briefly. I would encourage folks to visit sketchfab.com/Crow Canyon and look at the models that we have up there currently. And there's a section where you can provide comment. And if there's things about the model that you would like to know that aren't portrayed, by all means, let us know that, so we can create better models with better annotations and content that may appeal to folks who are using it. And really, we hope to beef that up in the coming years.
That's great. Milana had a question, and it was, you showed in one of your slides the 3D reconstruction of Sand Canyon, and you showed the artist renderings of a couple of the other basket maker pit houses. Is there a way to integrate both of those together? Do we have any plans to do more 3D modeling of sites before they degrade, right? To give people a better idea of the complexity of these villages.
Yeah, that's a really, really good point. And Moana's question is great. I think we want to take care with our reconstructions in terms of what we're portraying. And I think we need to consult with a lot of different folks, descendant groups especially, about how we recreate things to disseminate them to the public. But I think it's an incredibly important thing to do. And I think there'll be a lot of return for combining the models themselves with our recreations, a lot like that Kiva 107 model. There's things about that I really like. And you could even take it further and show the roofing structure. We haven't done that much yet, but I can definitely see that coming down the pike and being a valuable part of our outreach and education curriculum that we can provide remotely.
That's great. Thank you. All right, we've got a lot of really good technical questions, so I'm going to start going through them. Folks, we're not going to be offended, but we love for you to stay and listen because they're really interesting. All right, so you talked a bit about QA/QC, right? Using ground control points where we can actually take the physical measurements, and you said that even on that stone circle, 35 meters wide, we're getting centimeters, accuracy, which is incredible. Do we do anything with color? You're taking photos. Is there any color balancing that you do?
You can take color balancing initially. There's a setting on the drone where you can manipulate that to get the contrast that you're after. And there's also a stage in the processing and Agisoft photo scan where you can manipulate um, things like white balance in the images that you're processing. So there's definitely opportunities to do that. I would say, based on my experience, the best lighting is a nice even lighting, like a really cloudy day where there's not a whole lot of shadows and there's not a whole lot of places that are just in blazing sun that are difficult to adjust for, either while you're taking the photos or in processing. So even lighting is better. It tends to help the software recognize those tie points between images a little bit better than anything that I've found.
Got it. So some of that software can help, like with removing shadows, but it's best to just pick a good day at this point.
Good photo capture is over half the battle. If
Got
you
it.
get good photos to start with, your model will turn out a lot better.
Susan had a question about that. Just how do you hold the camera steady enough? Do you take way more pictures than you need and then select pictures so that you always get good ones that are in focus? What's the strategy there?
That's really the best way to do it, is collect all of the photos that you think you'll need and be redundant. That does create, of course, a bit of a storage problem if you have limited local or cloud storage for the images themselves. Mm-hmm. So you do want to think about it and not just take 8 million photos just to try to get everything, but you do want to catch more of the structure with more images than less. And it's important just to think about that judiciously and be reasonable in terms of your photo capture, because you can go overboard taking too many as well. I hope that makes sense.
Yeah, totally. Got a couple of questions that have to do with more landscape scale. So you showed one great aerial image of the area around the Haney Great House. And you were talking about how, especially the thermal imagery, can possibly be used to see ancient roads, that sort of thing. Have you heard of anybody doing it for ancient stream beds? We could clearly see stream channels there. Can you identify ancient ones?
I think potentially you could, based on the vegetative growth and the signature that you get from infrared. I have not personally seen that, but it would make sense in terms of the principle of trying to identify vegetative growth and heat signatures that relay a different underlying stratum, just like they would for roads or trails. So it seems like in principle it would work, but I've never really been involved and haven't seen that much. But
got it.
That's probably just me.
Hey, I think we should try it. It's great. It's a cool idea. Somebody asked, and this is interesting, most of the models you were showing were taken with either ground-based photogrammetry or drone photogrammetry. Do you combine those ever by doing both to get interiors, exteriors, ground-based, the whole picture?
You can. You definitely can. It's, at least in my experience, it's better if you're doing just like a landscape to use one camera, and it makes the processing a lot more straightforward, and there's less error just between camera images and how many megapixels one is versus another. But if you have good control points where you can see parts of the same structure, for instance, that you're trying to model from both aerial and ground-based, if you get enough shots with both of those things in there, the software can correct for that, and there are certain settings that you can apply. So you can do it. I think it's more difficult and cumbersome in terms of the processing, but it's definitely got a lot of upside to it too in terms of pairing the two.
Awesome. Then we've got one question here about the artifact analysis that we're doing. You showed some incredible images of vessels. Can those be used for estimating volume or vessel wall thickness, those sorts of things? And are we doing that yet?
Yeah, you can definitely use the models that you create to estimate volumes, and it works kind of like the example that I showed for the cross canyon circle, where you create the model and then you close all the holes. And when you close all the holes in the model, it gives you a volumetric estimate of how much that container could hold. Um, Doing the wall thickness is a little bit more tricky because in a lot of those vessels, it's really hard to get an image of the interior to create a model of the interior as well as the exterior. So you're oftentimes just using the skin on the outside minus the wall thickness of the vessel to create your volume, which isn't entirely accurate, but it can give you a pretty good estimate.
That's awesome. And then we've got two final questions that have to do with our sort of technical capacity. And I'm interested in this too. What is the future of digital storage for all of these data? How big are these in terms of space, and where should we start seeking long-term storage for these sorts of models?
Well, that's a really good question. I'm afraid I don't have all the answers to that one. It seems like at some scale, it's going to require cloud-based storage and really large servers to actually store the imagery. So far, I've been fortunate enough to work remotely or work locally on servers where I've stored them here at Crow Canyon. But it's a really big issue the more that this gets done. And what about archiving, and how do we make access available for people who want to use our imagery for testing their own hypotheses in the future? It really needs some kind of centralized repository that regulates but allows access to the imagery itself, cloud-based or some other way.
Right. Well, that about covers all of our questions. If I haven't asked your question, I'm about to type the answer to you. So hold tight. Grant, thank you so much for your presentation today. It was really great. Thank you all for joining us, and please join us again next week. This has been fun.
Thanks, Kyle. Thanks for your time, and thanks everybody for coming today.
All right. Bye, everyone.